Okay, this is lesson AMU5L5, and we are going to be finding side and angle measures using your trig functions. So for number one, we have a triangle and we have a 32-degree angle marked. We know this side is 11 and this is x. Now we're going to use the trig function backwards. So the hardest part is figuring out which function do I need to use. Okay, look at your angle and then you ask yourself, which sides do I have a value for and am I looking for? So from this angle, I know the side opposite and I'm looking for the hypotenuse. So which function uses opposite and hypotenuse? Well, that's going to be your sine function. So we're going to set up an equation that says, all right, the sine of my 32-degree angle is equal to the side opposite, which is 11, over the hypotenuse, which is x. Okay? Now, once we have this, we're ready to solve because you're going to be using your calculator. Sine 32 degrees is a number. Back when I was in school, we had a chart. We didn't have a calculator, but you had to look down a chart and find out what the number for sine 32 was. Now, we want to wait until the very end before we convert this to a decimal. So let's go ahead and solve down to that point. The first thing we're going to do is multiply both sides by x. Okay. Now we have x sine 32 is equal to 11. Now I'm still solving for x, so now x is multiplied by sine. Divide both sides by sine 32 degrees. And now what I have, these cancel out. So I have x is equal to 11 over sine 32 degrees. So if you go to your calculator and you punch in 11 sine 32 degrees, that's going to show you x equals 20.8. Okay, now let's look at number two. We have a right triangle. We have a 75-degree angle here. We have a side that's x and a side that's 21. So first we have to decide which function are we going to use. All right, from our angle, we want to know the side opposite, and we have a value for the side adjacent. So which of your functions uses opposite and adjacent? Well, that's going to be your tangent function. So that's how you choose it. Now let's fill it in. The tangent of the degree, which is 75 degrees, equals, all right, your side opposite, so that's x, over your side adjacent, so that's 21. I'm just using the definition, opposite over adjacent. Now you're just solving it like you would a regular equation, and you need to consider that this is just a number. That's a number, but we're going to leave it like this for now. All right, if I'm solving for x, I need to get rid of the 21. It's been divided by 21, so I'm going to multiply 21 on both sides. These cancel out, so now I have 21 times tangent 75 degrees is equal to x. So on your calculator now, you're going to push 21, the tangent key, 75 degrees equals, and that is going to show you 78.4. Now it's going to go out further than this, but your directions say just to go out to the nearest tenth. So that's all you had to do there. Okay, here's number three. So here's our triangle. First we have to figure out which function do we want to use. So look at your angle. Which side do you know and which side are you looking for? Well, I know the hypotenuse and I'm looking for the side adjacent. Now which function is it that uses side adjacent and hypotenuse? Well, that's going to be your cosine. So I'm going to set up my equation as the cosine of the 23-degree angle is equal to what? The side adjacent, which is x, over the hypotenuse, which is 30. That's just from the definition, okay? Now let's solve the equation. Here's my x, that's what I'm solving for. It's been divided by 30, so I'm going to multiply by 30 on both sides. So now I have 30 times cosine 23 degrees is equal to Those cancel out, so I have x. All right, when you punch in your calculator, 30, the cosine button, 23, hit enter, that is going to tell you 27.6, you round it off to the nearest tenth, is equal to x, and it really is just this easy. Okay, same thing for number 4. We have one angle and we have a side that we know, and we're looking for another side. So which sides are these? Well, here's your hypotenuse up here, and it's not involved at all. So what we have is the side opposite and the side adjacent. Now, which function is concerned with opposite and adjacent? Well, that's going to be your tangent. So we're going to say tangent of the degrees, which is 41, is equal to the side opposite, which is 15, over x. So to solve for x, first I'm going to multiply by x to get it out from under the fraction. So what that's going to do is give me x is equal to tangent 41 degrees. These cancel out, so now I have 15. Then I'm going to come back and I'm going to divide now by tangent 41, okay? So these two cancel, and now I have x equals 15 over tangent 41 degrees, and it is calculator time. So you're going to hit the 15, hit your fraction button, then hit the tangent button, and then 41, and that is going to give you 17.3. Okay, here's number 5. We have a right triangle, and we have a 64-degree angle, and this is x. Here's x, and here's the given side. So let's see, what do we have and what do we need? Well, we have the side adjacent, and we need the hypotenuse. So which of these involves adjacent and hypotenuse? Well, that's going to be your cosine. So now that we've chosen it, so therefore the cosine of 64 degrees is equal to the side opposite, the side adjacent, which is 3, over the hypotenuse, which is x, okay? Now we're just solving for x. Since it's in the denominator, the first thing I'm going to do is multiply it by both sides to get it up from the denominator, even though it's going to move it to the other side. And those cancel. Now, I want x by itself. It's multiplied by cosine of 64. So I'm just going to divide by cosine 64 on both sides. Okay. These two cancel out, so I have x equals 3 over cosine 64. And calculator, 3, fraction button, cosine 64 is going to let you know that x is equal to 6.8. Okay, for number 6, here's our right triangle. Now here's my angle that I have a degree measure of, and I have a measurement for the side opposite, and I want to know the side here that's opposite the right angle, so that's my hypotenuse. So which one involves the side opposite and the hypotenuse? Well, that's your sine. So the sine of 18 degrees is equal to the side opposite, which is 25, over x. And once again, since x is in the denominator, to get rid of it, I'm going to multiply by both sides, or rather to move it up from the denominator. It cancels here, so I have 25 degrees left, and over here I'm going to have x times sine 18, and that's not 25 degrees. Okay, now we are going to divide both sides by sine of 18 degrees. They cancel here, and this simplifies to x equals 25 over sine 18 degrees. And once again, you put that in your calculator, and it's going to spit out 80.9. Okay, in the last section, we were given an angle and a side, so we found a missing side. Now in this section, we're going to find out how to find a missing angle if we have two sides. And there's something new, there's a new definition that we're going to have a look at, and this is the inverse functions because we're going to go backwards, so we're going to invert it. Now this is just definition, so this is something you're going to have to memorize or learn it. It's not going to take but a second. And it says if sine of theta is equal to x, and all of these are the same for all the functions, if that theta is equal to x, then theta is equal to what we call the inverse sine of x. All right, sine -1, and the same thing with cosine. Then theta is equal to inverse cosine of x, and theta is equal to the inverse tangent of x, okay? So now let's look at your calculator. If you notice on your calculator, find the sign button, and right above the, or right under the sign, you see the sign -1. So what I want you to do first of all, just punch sine of 30 and hit enter. And what did you get? You got 1/2. Now, to hit the inverse sign, you're going to hit that button 2 times. That gets you sine -1. So that's your inverse sign. Now I want you to punch 1 fraction button 2 and hit enter. Now what'd you get? What it gave you was 30 degrees. So you see, if you had the degree measure, this gave you the ratio of the side opposite and the hypotenuse. But if you had the side opposite and the hypotenuse, going the inverse sine route will tell you what degree measure that angle is. Okay, so let's actually work some problems. So let's look at number 7 now. We have a triangle and it is labeled with this angle is theta. Now we know the hypotenuse is 23 and we know this side here is 18. We need to determine which function we want to use, and we do that just like we did in the other section. Let's identify the sides that we have. I have a hypotenuse and I have the side adjacent. Now which trig function is concerned with adjacent and hypotenuse? Well, that's going to be your cosine. So the way we're going to write this is, all right, the cosine of the angle that we're looking for, theta, is equal to the adjacent side over the hypotenuse. So this is 18 over 23. Now we're going to use that definition that we just did that said if you have cosine theta equals some number, some ratio, you can rewrite that as theta is equal to inverse cosine of 18 over 23. Now believe it or not, this is just a number. So how do you get this out of your calculator? Okay, you hit that cosine button twice so that you see the cosine, the inverse cosine with the -1, and then you do 18 fraction bar 23, and then you hit enter, and what that's going to tell you is that theta is, and we're just going out to the tenths, theta is 38.5 degrees, okay? Okay, let's look at number 8 here. I have theta marked and I have 2 sides, so let's identify the sides so we can figure out which function we want to use. All right, this is the side opposite and this is my hypotenuse. So which function is concerned with opposite and hypotenuse? Well, that's going to be your sine. So we're going to start off with, all right, the sine of theta is equal to my opposite over my hypotenuse. Then I'm going to apply that definition of inverse sine. And I'm going to say, well, if sine theta is equal to 5/12, then theta is equal to the inverse sine of 5/12. And then I'm ready for a calculator. So you're going to hit the sine button 2 times till you see sine with the -1 up there. Then you hit 5 fraction bar 12, and when you hit enter after that, it's just going to tell you, well, that's 13.8 degrees. So this one is 13.8 degrees. Okay, on number 9, let's label our sides so we'll know which function to use. Well, obviously, this right here is your hypotenuse. So what you have is your side adjacent and your side opposite. All right, and that's going to require the use of tangent. So I'm going to say, well, then the tangent of theta is equal to the side opposite which is 17, over the side adjacent, which is 18. Then I'm going to convert, use that definition. Therefore, theta is equal to inverse tangent of 17 over 18. Therefore, theta is, and I'm going to hit the tangent button twice, 17 over 18, and that's going to tell me 43.4 degrees when rounded off to the nearest tenth. Okay, for number 10, we have theta here, so let's identify our sides. This is the side opposite, and this is the side adjacent. So we're going to be looking at tangent. All right, the tangent of theta is equal to the opposite, 39, over the adjacent, which is 20. Using my definition, if this is true, then theta is equal to the inverse tangent of 39 over 20. And then when you type that into your calculator, that's going to tell you 62.9 degrees. Okay, for number 11, here's the information we're given. So let's identify the location of the sides. From here, this is my side opposite, and this is my hypotenuse. So which function do I need? That's going to be your sine. So sine of theta is equal to the side opposite, which is 29, over your hypotenuse, which is 52. Convert, then theta is equal to inverse sine of 29 over 52. Therefore, punch it in the calculator, and theta is 33.9 degrees. Okay, let's try number 12 now. Here's theta. So what do I have? I have my hypotenuse and I have the side adjacent. So which is that going to use? Well, that's going to be your cosine function. So cosine of theta is equal to the side opposite, the side adjacent, which is 12, over the hypotenuse, which is 19. Let's convert. So that's going to be theta is equal to inverse cosine of 12 over 19. And that's going to be time for your calculator. And when you punch that in, it's going to tell you 50.8 degrees. In this last section, we're going to be doing something called solving the triangle. Triangles have 6 parts. There's 3 angles and 3 sides. When you solve a triangle, that means you find all the missing parts. So you should have 6 numbers, 3 sides and 3 angles. Now, when we look at this one, we know that this angle is 90 degrees. We know that this one is 72. So what can I do to find what angle B is? And that's going to give me the answer here. Well, I can do 90 minus 72. And that's going to give me 18 degrees because the sum of the measures in a triangle is 180. Well, you've already got 90 down here in your right one, so 90 minus this one would have to give you this one. Okay, now we're going to need the trig functions for the other one. So let's just do BC here first. When you're using other measurements to find an answer, you always want to use the given measurement if possible. Now I know you could, we know all the angles, so you could go from any of them, but it's generally safer to use one that's given. That way if you messed up finding something else, you're not using a wrong answer to find another answer. So here we're going to take this, and I know the side adjacent, which is 15. I didn't mark it, but there. My side adjacent is 15, and I would like to know my side opposite. So which function is that? Well, that's your tangent. So I'm going to say, okay, the tangent of 72 degrees is equal to the side opposite, which is x, over the side adjacent, which is 15. And now I'm just going to solve this. So that's going to be 15 times both sides. These two cancel out, so I have x is equal to, and then we're going to use the calculator, 15 times tangent 72 times tangent 72, enter, gives me 46.2. So this is side BC. Okay, now let's find side AB. That's your hypotenuse right here. Now you've got two options. You could do the Pythagorean theorem, but you rounded off this number. So if you use the Pythagorean theorem, you know, you may get close or you may not. So let's see if we can focus on measurements that we were given. The 72-degree angle, I know the side adjacent and I'm looking for my hypotenuse. I could use cosine. So the cosine of the 72-degree angle is equal to the side adjacent, which was 15, over the hypotenuse, which is y. Now we're solving, so I'm going to multiply both sides by y. These cancel, and now I have y cosine 72 degrees is equal to 15. And then I would divide both sides by cosine 72 degrees. So now I'm going to have y equals, and I'm going to use a calculator, 15 divided by cosine of 72 gives me, to the nearest tenth, 48.5. So that is your missing side. So now you know all three angles and all three sides, and that is a solved triangle. Okay, for number 14, we're going to solve another triangle. So we start with our angles. I look inside. I see this is my right angle, so that's 90. I see this is 34. So the first thing I'm going to do to find this missing angle is subtract 90 minus 34. And that's going to give me okay, on number 14, here's the triangle with the information I'm given, and I want to find all my missing parts. So I'm just going to go ahead and label my two sides X and Y, so I know I'm going to be solving for them. First, let's focus on this angle over here, though. If I know that this is a 90-degree angle, then I know the other two have to be equal to 90. If I know this is 34, so I can say, all right, this angle is equal to 90 minus 34, and that's going to give me 56 degrees. All right, so that was the first part. Now to use my trig functions on the rest of this. This is the angle I want to use if possible, because that's the angle that was given to me. So if I'm looking for this side opposite and I have the hypotenuse up here, which function is that? Well, that's your sine function. So it's going to be sine of 34 degrees is equal to the side opposite, which is x, over the hypotenuse, which is 42. Okay? And then solving this, just like we've been doing, I'm going to multiply both sides by 42. Now these two cancel out, so I have x equals, and when I punch all that into my calculator, that's going to tell me 34.8. So my side RT is 34.8. Okay? So now let's find that other side. Nope. That is not correct. So let's start that over. And you need to pay attention to what you're doing. And then you won't have to keep working these over and over and over. Okay, let's look at number 14. I'm given that this angle is 34, and I know that this is a 90-degree angle. I'm given one side. So I'm going to go ahead and label the missing sides X and Y. And let's see, this was T down here. So let me come over here. X is RT and Y is STTS. All right, now we're ready. To find this missing angle, well, that's going to be an easy one. I know the other two. So I can say 90 minus 34 will give me 56 degrees. All right, so that's this one. Now, as far as finding these other two sides, I'm going to use my trig function. So let's focus on one at a time. From angle 34, this is my hypotenuse. And this angle, this side, side x, is my side opposite. So which function uses opposite and hypotenuse? That's going to be your sine. So the sine of 34 degrees is equal to the side opposite, which is x, over the hypotenuse, which is 42. And now solving just like we've been doing. We're going to multiply both sides by 42. And that's going to give me x equals, all right, it's time for the calculator. 42 times sine 34 will get you 23.5 degrees. And this was RT, and that's not degrees, I'm sorry, that's length, okay? 23.5. So now, let's find the other one. All right, going back to the 34 degrees, this side is my side adjacent. Now, which function deals with side adjacent and hypotenuse? Well, that's going to be your cosine. So to solve for this side, I'm going to say, all right, then the cosine of 34 degrees is equal to the side adjacent, which is y, over the hypotenuse, which is still 42. I'm going to multiply 42 on each side. And these two cancel, so I have y. Now, in the calculator, 42 times cosine 34 is going to get you 34.8, rounded off to the nearest tenth. And that's my other missing side. Okay, let's look at number 15 now. We have this triangle, and we have two sides. And we know this is a 90-degree angle, but we need to find both of these angles and this side. So what I would start with, since we know two of the sides and we're missing a third side, let's just use the Pythagorean theorem. So this is your hypotenuse, and we're going to have 7.6 squared plus, all right, this side is going to be x squared, is equal to the hypotenuse squared. So 7.6 squared is going to be 57.76 plus x squared is equal to 64. If you subtract 57.76 from each side, that's going to give you x squared is equal to 6.24. And then if you take the square root of each side, you're going to get x is equal to 2.5. So this side here, this side of the triangle is 2.5. All right. Now we need to find an angle. And I would go with K. I mean, you could start with L, but let's go ahead and go with K. And I'm looking at the sides that were given to me. I know this side adjacent, and I know my hypotenuse. So which function is it that goes with side adjacent and hypotenuse? That's your cosine. So I have the cosine of, and we'll just call this angle K, is equal to my side adjacent, which is 7.6 over 8. All right. Now, do you remember your inverse functions? So what we can do here is say, all right, then K is equal to inverse cosine of 7.6 over 8. So if you take your calculator and you punch, hit the cosine button twice to get your inverse cosine, and then 7.6, fraction button 8, and then you hit enter, that's going to tell you 18.2 degrees. All right, so now we know that one. All right, now that we know that angle, well, you know two of the angles in here, so just do 90 degrees minus the 18.2, and that's going to give you 71.8 degrees for that remaining angle. Okay, let's have a look at number 16. We're given two sides, and we know this is a 90-degree angle, and that's all we're given. Well, first of all, you know, if you have two sides of a right triangle, you know you can use the Pythagorean theorem to find this third side. So let's do 21 squared plus 22.5 squared is equal to x squared since I have it labeled that. So when you square 21 and square 22.5 and add them together, you're going to get 947.25 is x squared. And then if you take the square root of each side, you get that x is equal to, and that's going to round off to 30.8. So the length of DF is 30.8. All right, now as far as finding these two angles, once we find one, we'll have it made because we can just subtract from 90. So look at the two sides we have. Let's do angle D. It really doesn't matter. The two sides that we have are the side opposite and the side adjacent. So we're going to say, all right, the tangent of D, angle D, is equal to the side opposite, which is 22.5, over the side adjacent, which is 21. All right, now that we want to know an angle and we have the two sides, that's when we bring in the inverse function. So I'm going to find tangent, inverse tangent of 22.5 over 21, and that's a calculator problem. Hit that tangent button twice to get the inverse, and then 22.5 over 21, and hit enter, and that's going to round up to 47 degrees. It's like 46.9.7, so you'd have to round, by the time you round the 9 up, you've got to round up to 47. So angle D is 47 degrees. And now you can just subtract, say 90 minus 47 for angle F, and that's going to get you 43 degrees.